Good day, learners. Yeah, welcome back to our class today. In today's class, we are going to continue the topic on geometric progression. I want you to follow me fully on this in order to look at the common mistakes that most students made in this topic and the best way to solve these questions using the WAEC and JAMB questions. So do not leave and sit back to unlock this trick. I remain your tutor, Latif Ismaila Akambi, your mathematics and chemistry tutor. So let's move on. The word geometric progression simply refers to as a sequence in which each of the preceding term is gotten by either multiplying or dividing by a common factor. Sometimes geometric progression could be referred to as a quotient. In what way? Let's assume we have this sequence 5, 10, 20, 40, and 80. Now, we all know from our previous classes that this 5 is called the first term, this is the second term, third term, fourth term, and the fifth term. Now, our first term, we normally denote our first term with A. So our first term, A, equals to 5. Then the second term here, if this one is our first term, T1, T2, T3, T4, T5. So T1 is denoted as A. Then T2, which is the second term, is going to be the division of the second term and the first term. So T2 is going to be 10 divided by 5, which gives 2. Likewise, third term will be given as 20 divided by 10, which gives 2. When we continue like this, we are going to get the same common factor, which is what? Which is 2. So if I multiply this first term by 2, I will get 10. Multiply this 10 by 2, I will get 20. 20 by 2, I will get 40. 40 by 2, I will get what? 80. If this is the case, then this 2 that is common to every one of them is what we refer to as the common ratio. As what? Yes, the common ratio. So if my first term is A, that is my T1 is A, my T2 is going to be A multiplied by R, which is my common ratio. So my third term, T3, will now be AR multiplied by another R, which gives me AR raised to power 2, because this is 2R. R raised to power 1, R raised to power 1 gives what? 1 plus 1. We have 2 raised to power what? 2. My T4 is going to be AR times R, which gives me AR raised to power 3. When we continue like this, till we get to what is called the nth term of this geometric progression, that is the nth term denoted as Tn or Un, will now be equals to AR raised to power n minus 1. So this is now the nth term of a geometric progression. That is the formula that we are going to be using in solving this geometric progression. Tn equals to AR raised to power n minus 1, or you say Un equals to AR raised to power n minus 1. Don't forget, from our arithmetic progression, I gave you the definition of each term, where this n or Tn means the last term or the nth term. So when it refers to the last term or the nth term. Where this A means first term, R now means common ratio. Then this n is the number of terms we are looking for, or how many times this thing occur. Example 1. Find A, the 8th, B, 34th, and C, nth of the GP 10, 20, 40, and 80. Given this particular GP, we have 10, 20, 40, and 80. The first term here, that is the first term, the first number here is 10. It's called the first term. Then, if you look at this, when we look at this, 20 minus 10 is going to give us 10. 40 minus 20 give us 20. Definitely, This one is not an arithmetic progression. But when we say 20 over 10, we are going to have 2. 40 divided by 20, we are going to have 2. This is talking about a common ratio. So common ratio R equals to 20 over 10, which is equals to what? 2. Now, to solve question A, you want to find the 8th term. Don't forget our formula, un equals to AR raised to power n minus 1. So when our n equals to 8, that is the 8th term. Our n equals to 8. That's the number of 10. Then we have u8 equals to our first term is 10 multiplied by our common ratio is 2. Then the number of 10 n equals to 8. So we have 8 minus 1. So we have 10 multiplied by 2 raised to power 8 minus 1, we have what? 7. So 10 multiplied by, so 2 in 7 places, 128. So when you multiply, we have 1280. So our 8th term is 1280. Question B, the 34th term. That is when n equals to 34. Still, by our formula, u34 equals to our first term is 10 multiplied by our common ratio is 2 raised to power n is 34. 34 minus 1. So we have 10 times 2 raised to power 34 minus 1, we have 33. So in this case, 2 in 33 places. So it will look too long. So it's better to leave our answer this way. Question C. You want to find the nth of the GP. Nth. That is our n equals to n. From our formula, un equals to AR raised to power n minus 1. Our n remain n. Un equals to our first term from here is 10 multiplied by our common ratio is 2. Our n equals to n minus 1. So that is our final answer. There's nothing that we can do to it again. There's nothing. Or we can do it this way. Let me do it this way. This 10 can be written as 2 times 5. Then times 2 raised to power n minus 1. And we know this 2 has a power of what? 1. So let's take this and this together. 2 raised to power 1 times 2 raised to power n minus 1 times 5. According to what we learned in our indices. Pick one of these two. I have 2 raised to power 1. Then this multiplication turns to addition plus n minus 1 times 5. Then we have 2 raised to power. So 1 minus 1 give us 0. That's when you say 1 minus 1 plus n times 5. So 1 minus 1 is 0. So this is going to be 2 raised to power n times 5. So 2 raised to power n multiplied by 5. So these are our un. So we can now move on to the next question. If you are just joining us for today and you've not subscribed to my channel, kindly subscribe to my channel and hit the notification bell for my subsequent contents. So let's move on. Example 2. If the first, second, and last term of a GP are 4, minus 20 and minus 12,500 respectively, find the number of terms in the GP. Let's interpret this. If the first term, A, second term, and last term of a GP are D. So first term is 4. My second term, don't forget our second term then, that is AR equals to minus 20. And last term, our last term, don't forget what they call last term, UN means last term, equals to minus 12,500 respectively. Find the number of terms in the GP. Number of terms means find your n. You want to find the number of terms, n. And don't forget, since we know that we are dealing with GP, the formula that comes to mind is what? Yes, that is the formula. UN equals to AR raised to power n minus 1. But before we move on, we have our first term A. There's something that we have to get. What is that? Common ratio. And we don't have it yet. And our common ratio is being embedded in this AR to be what? Minus 20. Don't forget that in our first term, to get our common ratio, when we first started, it is the second term divided by what? First term. So common ratio, so from here, our first term T1 equals to A equals to 4. Our second term T2 equals to AR equals to 20. So from here, so let us now go this way. T2 over T1 is equals to, our T2 is AR over our T1 is A. Then what's our AR? Don't forget it's minus 20, not 20. Minus 20 over 4. A cancel A, our R is out. 4 here 1, 4 here 5. So R equals to minus 5. We've gotten our common ratio also to be minus 5. Then we now go back to our formula, which is UN equals to AR raised by n minus 1. What is my UN? Minus 12,500 equals to, my first term is 4 multiplied by my common ratio that I got, minus 5 raised to power what? N minus 1. Now the first thing is, let me find a way of taking away this 4. And this 4 is joined to this one by multiplication. Why am I taking this 4 away? Because 4 does not have power of n like this 5. So in this case, I have to take it away. And the opposite of multiplication is division. I have to divide both sides by 4. Minus 2,500 divided by 4 equals to 4 multiplied by minus 5 power n minus 1 divided by 4. 4 cancel 4. 4 here 1. 4 goes in 12, we have 3. In 5, we have 1. Remainder 1. Put it here, making 10. 4 goes in 10, we have 2. Remainder 2. Then put it here, making 20. 4 goes in 20, we have 5. So we have minus 3,125 equals to minus 5 raised power n minus 1. Fine. I want this to have the same base, because this is base 5. Then, if you continue to undergo long division, to divide this one by 5, you see that 5 in 5 places will give me 3,125. So I'm going to have minus 5 raised to power 5, which now equals to minus 5 raised to power n minus 1. In our indices, the base, when they are the same, what are we going to do? Minus 5 cancel minus 5. So 5 will now equals to n minus 1. I need my n. I have to take minus 1 to the other side. I have 5 plus 1 equals to n. So 5 plus 1, 6 equals to n. Therefore, my n equals to what? 6. So the number of term in this case equals to 6. Do you get it now? Okay, for more clarity, let's take one more example. Example 3. The third and fifth terms of a geometric progression are 9 over 2 and 81 over 8 respectively. Find the A, common ratio, B, first term. Now let's look at this. The third and fifth term of a geometric progression are these. What is third term? Third term is AR raised to power 2. This is not about cramming. You don't need to cram it. Once you know your formula, UN equals to AR raised to power n minus 1. So the size is third term. It means if I put 3 here, 3 minus 1 will give me 2. So AR raised to power 2. So which means the third term, which is AR raised to power 2, is equals to 9 over 2. Let's see, this is our equation 1. And the fifth term is equals to 81 over 8. So if I say the fifth term, what is going to be? Yes, it's going to be taking away, putting 5 here. 5 minus 1, we have 4. So we now have AR raised to power 4 is equals to 81 over 8, equation 2. I need my A, I need my R, but my common ratio first. Don't forget what I told you about geometric progression. Sometimes they are referred to as a quotient. That is division. That is, question A, I can divide equation 2 by 1. And my equation 2, a raised power 4 over a raised power 2 equals to 81 over 8. That is equation 2, 81 over 8 divided by equation 1, 9 over 2. A cancel A, isn't it? Now pick one of these R here, according to our indices. R raised power 4. This divided indices change to minus 2 equals to 81 over 8. This division will change to multiplication. In this case, 2 will move up over what? 9. So we now have R raised power 4 minus 2, I have 2 equals to, now 2 goes here, 1, 2 goes here, 4. 9 goes here, 1, 9 goes here, 9. That is 9 times 1 is 81. So from here, I have 9 times 1, 9 over 4 times 1, 4. So R squared equals to 9 over 4. I need my R and not R squared. I will now say R raised power 2 equals to 9 can be written as 3 raised power 2 over 4 can be written as 2 raised power 2. That is R squared equals to 3 over 2. They both have 2 in common. So this power of 2 cancel power of 2. R equals to 3 over 2. You can see I'm able to get my common ratio. Now, how do I go about my first term? I can get my first term using any of equation 1 or equation 2 since I've gotten my R. Let me use equation 1. From equation 1, AR squared equals to 9 over 2. That is A multiplied by, what is my R? 3 over 2. 3 over 2 squared equals to 9 over 2. So A times 3 times 3, 9 over 2 times 2, 4 equals to 9 over 2. Don't forget, if you look at this now, I need my A. I want to get rid of this 9 over 4 to remove it. How can I take it away? It's by looking for the opposite of multiplication, which is what? Division. I have to divide both sides by 9 over 4. A multiplied by 9 over 4 divided by 9 over 4 is equal to 9 over 2 divided by 9 over 4. This cancels this. My A equals to 9 over 2 times 4 over 9. 9 cancel 9. 2 here 1, 2 here 2. Therefore, my A equals to 2. Finally, I'm able to get my A and to get my what? R. So, this is the simple ways of solving geometric progression. I believe the explanation is very, very clear. If not clear, please leave your comments in the comment section. Then let me know where it is not clear so that I can use more examples to buttress my class. Don't forget to subscribe to my channel if you have not done so, and click the notification bell for my subsequent content. Do well also to share, like, and leave a love emoji as you leave this channel. So watch out for the next class when we'll be solving more questions on WAEC and JAMB past question. Thank you very much.